Inshallah, in this class, we are going to discuss about the diagonalization by orthogonal reduction method. Before going into method, let me have few concepts. See, I wrote few steps on the board. First step is see what first statement. If suppose we are having x1 transpose into x2 equals to 0, vector x1 transpose vector x2 equals to 0. If we get after multiplying get the value 0, then we say x1 and x2 are orthogonal vectors. Then we say x1 and x2 are orthogonal vectors. This we must know. Suppose we multiply x1 transpose x2, we get value 0. Then we say that the two vectors are orthogonal vectors first. And second step is if A transpose equals to A transpose equals to A, then A is called symmetric matrix. Then A is called symmetric matrix. Now see example, how to, you must understand symmetric matrix. These two values will be always equal. You see this two equal and this two will be equal and this two will be equal. See here, both 2, both -4, both 5. Whatever may be the values in the diagonal, no problem. These numbers can be any numbers, but if this 2 and this 2 and this 2 are equal, then this will be a symmetric matrix. This 2 equal, this 2 and this 2. Whatever be the numbers in the diagonal, no problem. So this is a diagonal matrix, sorry, symmetric matrix. Here also you see these two numbers are equal and these two numbers are equal and these two are equals. So this is called symmetric matrix. Okay, now you see this is very important step for symmetric matrix. If it have distinct eigenvalues, distinct eigenvalues means different eigenvalues, that is all the values of lambda are different, suppose 1 2 3 or 4 2 3. If we get any two values equal, then the method will be changed. If we get any two equal values, then the method will be changed. If we are having all the different values, then the pair of corresponding eigenvectors, then all the eigenvectors will be always orthogonal, pairwise orthogonal. That is, if you multiply x1 transpose into x2 or x2 transpose into x3 or x3 transpose into x1, you will get always 0. Again, you understand this word. For a symmetric matrix, if it have distinct eigenvalues, yani different eigenvalues, all the values are different, then the pair of corresponding eigenvectors, are always orthogonal to each other. That is, x1 x2 and x2 x3 and x3 x1 are orthogonal to each other. If the values are not distinct, it may be orthogonal, it may not be orthogonal. We will discuss in the later class. If the eigenvalues are same, repeated, then the algebraic multiplicity we have to see. Okay, that concept will be changed. We may discuss this afterwards, but no, we are doing questions on the based on different eigenvalues, distinct eigenvalues. Then the corresponding eigenvectors will be always perpendicular, that is orthogonal. We'll discuss in the question, just you remember this one. Now method, diagonalization by reduction, orthogonal reduction method. How to diagonalize orthogonal reduction method? This is for especially for symmetric matrix. For symmetric matrix, if the matrix is symmetric, then we can use orthogonal reduction method. Diagonalization by orthogonal. The first step is same, find eigenvalues. Previous class we have done this one. Second step is also same, find eigenvectors. We already done this one also. Now write model matrix also. We also discussed this in the last part, x1 x2 x3. Now the next only two steps will be changed. First step is normalized model matrix. What is normalized model matrix? Its formula will be x1 by mod of x1, x2 by mod of x2, x3 by mod of x3. Now, how to find mod? You see example. Suppose here I wrote one example. So if x1 equals to 1 2 3, then mod of x1 will be under root of this squares, that is 1 square plus 2 square plus 3 square. This is root 14. So we have to divide this by root 14. For example, see here, we write this mod x1 by mod x1 means 1 by root 14, 2 by root 14, 3 by root 14. So we call this as x1 by mod of x1. So how to write normalized model matrix? We note this by P equals to x1 by x2 mod of x2, sorry, x1 by mod of x1, x2 by mod of x2, x3 by mod of x3. We see detail in question. Okay, the next step is last, only the light differences. In the previous section we have to find P inverse, but here in orthogonal reduction method and symmetric method, P inverse is equals to P transpose. So finding P transpose is very easy. No need of finding P transpose. Sorry, P inverse. So in orthogonal reduction method, instead of finding P inverse, we use P transpose, because here P inverse is nothing but P transpose. So very easy to find P transpose. Just will change the rows into columns or columns into rows. So we have to find the next step, P transpose. Lastly, the step is diagonal matrix. In the previous class, what we did, the diagonal matrix formula is P inverse into A into P. The only difference here is, instead of P inverse, we use P transpose. Inverse of P inverse, we use P transpose, because here we have P inverse and P transpose same. So instead of P inverse, we write P transpose into A into P. Just recall the method. What is the first step? The first step is we have to find eigenvalues, then eigenvectors, then model matrix, then the new step here, normalized model matrix, x1 by mod x1, x2 by mod x2, x3 by mod x3. Then lastly, instead of P inverse, we find P transpose. Then diagonal matrix will be D equals to P transpose into A into P. Let me do one example. We already done how to find the eigenvalues and eigenvectors. So we write that in short. Okay. The actual method is we have to discuss this part only. Now you see one example I wrote to save the time. I already written it, you just follow it. Okay, now to find, first, what is the first step? To find the eigenvalues, we have characteristic equation A minus lambda equals to 0. We already know what is A minus lambda. You just apply minus lambda with three these elements: 3 minus lambda, 5 minus lambda, 3 minus lambda, 3 minus lambda, 5 minus lambda, 3 minus lambda. You write all the numbers as it is, the remaining numbers. Now the next thing is, now you expand this determinant. First write 3 minus lambda, you had this into this minus this into this. Now always change the sign. This is minus 1, now write plus 1, you had this minus 1 into 3 minus lambda, minus 1 is plus 1. The lastly 1 into, you had this minus 1 is plus 1 minus 1 into 5 minus lambda. Now multiply this, 5 3s are 15, 5 lambda, 3 lambda, lambda square minus 1. You multiply this also and this also. I'm showing this shortly because to reduce the time of the video. Okay, to save the time. Now you add this one, though multiply this. Now we'll get a quad cubic equation. This, if you solve this, we'll get a cubic equation. And already I shown this cubic equation can be taken out from calci. If you take out the values from calci, you will get the lambda values 2 3 6. We have already done these types of questions in the previous classes, how to use the calci and how you to multiply this, all the things we have seen in the previous classes. So if you even have not seen the previous parts, I request you to see the first previous parts. Now we will continue. This is the values of the lambda. Now this is called the eigenvalues. These are the eigen values. Now we have to find the eigenvectors. Let me continue this one. Now for each particular value of lambda eigenvalue, we have to find eigenvector. For eigenvector, we have to substitute A minus lambda into x equals to 0. A minus lambda is already we have. So I am writing A minus lambda into x. X is taken as x1, x2, x3. Okay. First case, we keep lambda equals to 2. We will get one eigenvalue. Then we keep lambda equals to 3, second eigenvalue. Then lambda equals to 6, third eigenvector. So let's start with lambda equals to 2. If you keep lambda equals to 2 here, this 3 minus 2 will be 1, minus 1, 1. 5 minus 3, 2 will be 3. And 3 minus 2 will be 1. So now you multiply, matrix multiplication, row into column. 1 into x1 is x1 minus x2 plus x3 equals to 0, minus x1 plus 3x2 minus x3 equals to 0, 3x2 minus x3 equals to 0. Now lastly, 1 into x1 minus x2 plus x3 equals to 0. Now solve any two equations. Let me solve first and second. How to solve? We start with the middle and end with the middle. Coefficients minus 1, 1, 1, minus 1. Here I wrote. Now see here, 3 minus 1 minus 1, 3. Start with the middle term and end with the middle term. 3 minus 1 minus 1, 3. Now see here. Now cross multiply x1 by minus 1 as plus 1 minus 3 minus 2. x2 divided by minus 1 minus 1 is plus 1, 0. x3 divided by 3 minus 1 is plus 3 minus 1 will be 2. Now you see we cancel this one, 2 ones are 2 ones. So we can have the first vector minus 1 0 1, minus 1 0 1. Now next case for lambda equals to 3. If we keep lambda 3, 3 minus 3 is 0, 5 minus 3 2, 3 minus 3 0. Again you multiply. If we multiply row into column, we get 3 values, 3 eigenvector, 3 equations. Now let us solve the first and second. Minus 1, 1, 0, minus 1. 2 minus 1 minus 1, 2. x1 by minus 1 is 1 minus 2 minus 1. x2 divided by minus 1 minus 1 is 0 minus 1. x3 by 0 minus 1 minus 1. See here, this 3 minus we can cancel. Minus you cancel this one. You will get the second vector 1 1 1. In the similar way, if we keep lambda equals to 6, we get the matrix. Now you multiply this one. In the second, we are having minus minus minus. I am taking minus common, so this will become plus plus plus. So second equation will be x1 plus x2 plus x3. See here. Now solve any two. Now we got the third eigenvector. So the first step and second step are finished. First step eigenvalues and second step eigenvectors. Let me continue with this in from the starting of the board. Now see here, I will show one example. You watch here. Now we got the three eigenvectors x1, x2, x3. Now what happens? You see x1 transpose into x. What we will get? x2. Sorry, x1 transpose. x1 transpose means you change this row column into row. This will be like this: minus 1 0 1 into 1 1 1. x1 transpose into x2. If you multiply, you will get minus into plus, minus 1 plus 0 into any number 0 plus 1. So this will be minus 1 plus 1 cancel 0. Therefore you got x1 transpose x2 equals to 0. No need to solve all this. That means if two vectors are multiplied, you get 0. That means these two are orthogonal. Therefore we can write this. I know. Similarly, all the three we can write like this. Since x1 comma x1 comma x2 and x3 are pairwise orthogonal. Pairwise, these are all orthogonal. That means if we multiply, we will get 0. Therefore, for this we can use orthogonal reduction method. Therefore, we can use orthogonal reduction method. What is the next step? We have to write model matrix. Model matrix. Now, model matrix formula is x1, x2, x3. So, what is x1? We are having x1 is minus 1, 0, 1. x2 is 1, 1, 1. x3 is 1, minus 2, 1. Now for normalized model matrix, next step is normalized model matrix. We have already discussed in the starting of the class. For that, let me find the mod x1. Mod means under root of square of this 3. Minus 1 square, 0 square, 1 square. This will be root 2. Now mod of x2. Under root of 1 square plus 1 square plus 1 square, 1 plus 1 plus 1, that is 3. Now mod of x3 equals to under root of 1 square 1, 2 square 4, 1. So if we divide by this mod values, we will get normalized model matrix. So let me write normalized model matrix. model matrix. So the normalized model matrix is P equals to x1 by mod of x1, x2 by mod of x2, x3 by mod of x3. Now x1 you divide by mod x1, this is x1, so divide by mod x1, this will be minus 1 by root 2, 0 any number 0, 1 by root 2. Now here by root 3, no, this is by root 3, 1 by root 3, 1 by root 3, 1 by root 3. Now this is 1 by root 6 minus 2 by root 6, 1 by root 6. So this is the value of P. Now in next step we have to find P transpose. We have to find P transpose. We already know what is P transpose. You change the columns into rows. So this will be like this: minus 1 by root 2, 0, 1 by root 2. Then 1 by root 3, 1 by root 3, 1 by root 3. Then lastly 1 by root 6 minus 2 by root 6, 1 by root 6. Now only two steps are left. Next step is diagonal matrix. Now the formula of diagonal matrix. Diagonal matrix is denoted by D. Its formula is P transpose into A into P. So D equals to P transpose, we got this value, minus 1 by root 2, 0, 1 by root 2, 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6 minus 2 by root 6, 1 by root 6 into A. The value of A is the given question: 3 minus 1, 1 minus 1, 5 minus 1, 1 minus 1, 3 into P. P we are having here. So if we multiply this, will be minus 1 by root 2, 1 by root 3, 1 by root 6, 0, 1 by root 3 minus 2 by root 6, 1 by root 2, 1 by root 3, 1 by root 6. So the last step, no need to multiply this all. If we multiply this all, we'll get the eigen values in the diagonal. So first value what we have taken, 2. So we'll get 2 here, 0, 0, 0. Second eigenvalue we have taken 3. So we'll get 3 here, 0, 0, 0. Third value we have taken 6. So you get here 6. You will get 6 here. So this will be the diagonal matrix. And this P is the similar matrix. We diagonalize A into diagonal matrix. So this is the question. Okay. This question is applicable only when we are having different values of lambda. If we have two values similar to the lambda, sometimes we not get a orthogonal pair of orthogonal eigenvectors. Then we have to change. Okay, let we see that in afterwards in the coming inshallah parts inshallah. Now you practice these questions inshallah. You practice these questions inshallah. We'll continue in the inshallah next class.